Dear students, I am going to take a basic maths for you. So this year some of the topics, earlier topics are retained and some of them are deleted. So I will give now the retained syllabus chapter wise and I will just read it one by one. So first one, matrices and determinants. Second one, permutations and combinations. Third one, probability. Fourth one, binomial theorem. Fifth one, partial fractions. Sixth one, mathematical logic. Seventh one, ratio and proportions. Eighth one, bill discounting. Ninth one, stocks and shares. 10th one, learning curve. 11th one, LPP, that is linear programming problems. 12th one, sales tax and value added tax. 13th one, heights and distances. 14th one, compound angles, multiple angles, submultiple angles and transformation formulae. 5th one, circles, point of intersection of line and circle. So these are the chapters, these are retained. Remaining topics are removed from the syllabus. So now let me start with the first chapter, chapter 1, determinants and matrices. So chapter 1, determinants and matrices. Or matrices and determinants. Matrices and determinants. So I will start with matrices. So what is the definition of a matrix? First of all, the definition. A matrix is a rectangular arrangement. Is a rectangular arrangement of numbers and numbers or functions. A matrix is a rectangular arrangement of numbers or functions. Now I will give you the general form of this. I mean, how to represent a matrix. A matrix is generally represented using capital letter. Using a capital letter, we can represent a matrix. So general form I will give. I will give it as a let A. A is a matrix. I will write the elements within the square brackets or round brackets. Let me write the matrix elements within the square brackets. So I am writing the general form. Say first element A11, I write it as A11, second element A12 and so on. So nth element I will write it as A1n. Similarly, next element I will write as A21, A22 and so on, A21, A2n, and this will continue like this, and AM1 There are horizontal lines, vertical lines. So this will form the horizontal line. So this horizontal line, okay, there are different horizontal lines. In fact, m horizontal lines are there. We call them as rows. So these are the rows. This is the first row. This is the first row. This is the second row. Again, this is row 2, row number 2, row number 1, and so on. So this is row number n. Row number m. Similarly, if you consider the vertical line here, vertical line like this, okay, the elements are A11, A21, and so on. AM1, here next A12, A22, AM2, dash dash, A1n, A2n, AMn. All these forms what are called as columns. So these vertical lines forms columns. The first one is column 1, second one is column 2, and so on. This is column n. So when I say matrix, it's a rectangular arrangement of numbers or functions. These are some numbers. You can assign any number here, you can give any number here, or any function also, like trigonometric functions like sin x, cos x, and so on. Any function can be given here. Okay, let me explain again this one. Here there are m rows, row 1, row 2, row m, and there are column 1, column 2 up to column n. See here, observe A11, A12, A1n. So in this row there are n elements. In this column there are m, okay, elements. What I am saying here is there are m rows here, A11, A11, A21, dash dash, AM1. So there are m rows and there are n columns, 1, 2, 3 up to n. So this is a general representation of a matrix. We say that it is of order m cross n. We say that it is of order m cross n, and I will write like this. So the matrix what I am giving is of order m cross n. It means that this matrix has m rows. M cross n means it has m rows and n columns. It has n rows and n columns. I will explain this with some simple examples. Now let A equal, I will call one matrix as A, which contains the number say 1, 2, 3, 4. So as I told earlier, we represent the matrix using any one of the capital letter A to Z, and the numbers are written either in square brackets, either use the square bracket or use the round bracket. I have used the square bracket here. So I have written A equal to 1, 2, 3, 4. This means that it has two rows, row 1, row 2. Similarly, it has column 1, column 2. So this has two rows and two columns, and we say that this matrix is of order 2 by 2. We write as 2 cross 2, which is read as 2 by 2 or 2 cross 2. So this is one example of a matrix of order 2 by 2. Okay. Next, some more examples I will specify or I will give. The next example is, say I will use another letter, say B. Let B equal to, so I will write as 1, 2, 3, 4, 5, 6. So in this example, you must observe that there are two rows. So this is first row, row number 1. This is row number 2, row 1 and row 2. How many columns are here? There are 3 columns. So there are 2 rows and 3 columns. So this will become 2 by 3 matrix. So 2 by 3 matrix where the number of rows m equal to 2, number of columns n equal to 3. So this is an example for 2 by 3 matrix. It is of order, we say that the matrix B is of order 2 cross 3 or 2 by 3. So in general, if I say that a matrix is of order m by n, it means that there are m rows and n columns. Okay. Next topic is types of matrices. Types of matrices. Types. First one, a row matrix. Row matrix. A row matrix has only one row. A matrix having only one row is called a row matrix. Example. X equal to only one row is there, so I can write A, B, C. Observe here, always matrices are represented using capital letters and the numbers or the values or whatever variable you are writing, whatever the elements, what are writing here, the values, the elements, we call them as elements, should be written using small letters if at all you are using letters. If at all we are using letters, the elements are to be written using small letters. This is the important concept you have to remember. Use capital letters for representing the matrix. Use small letters representing the values or elements. Values are elements within the matrix. And also I told you, you should give either square brackets or maybe you can give round brackets also, that's also okay. One more example I will give you, x equal to or a equal to, I will write again say AB. So this is again, okay, this is again a row matrix which is having only one row. Only one row is present here, but there are 2 columns actually. There is one row, only one row, 2 columns. 2 columns. Column 1, column 2. So again observe that the letter I have written is A, which is capital. I have also used the letter A here, B here, but these letters A and B, for example A, this is small letter. So this is entire, this A is entirely different from this A. This A represents that it is a matrix. What about this A represent? This A represents, small letter A represents, it is an element of the letter A, I mean the matrix A. So small a is an element of the matrix A. A is the name given for this entire matrix, whereas small a is the element of the matrix. So come back to the row matrix. Row matrix means only one row. A row matrix, easy to remember. A stands for one, single. Similarly, the next one is column matrix. Next one, column matrix. Column matrix, again name suggests it has only one column. call it as column matrix. There is only one column. Only one column. So that is why it is called a column matrix. Of course, there are 3 rows here, but that doesn't matter. 3 or 4, whatever number of rows doesn't matter. Only that matters is how many columns are there. So the name suggests column matrix. A single column. It contains only single column. Next, null matrix or zero matrix. Null or zero. Either the word null or zero. Null or zero matrix. Null or zero matrix. Name itself again suggests. So what it suggests? The elements contains zeros only. Matrix having only zero values. So only zero values. Number 0. Okay, number 0. Zero is only present in the zero matrix. Example. So all the elements should be 0 here, 0, 0. So this is a null matrix of order 2. So for null matrix, actually we have a different notation. We will use the letter or symbol like this. So we will give a big 0 or O. This is the way how we can represent null matrix. Null matrices are represented as using this symbol. So this is a null matrix of order 2 by 2. One more example. Okay, this is of order 2 by 2. Null matrix. So this is null matrix can be like this also 0, 0, 0, 0, 0, 0. This is again a null matrix. It is of order 1, 2. So 2 rows are there, 3 columns are there. It is of order 2 by 3. 2 rows and 3 columns. 2 rows and 3 columns. It is of order 2 by 3. That is about null matrix. Next, rectangular matrix. Rectangular matrix. Rectangular matrix. A matrix is said to be a rectangular matrix if number of rows not equal to number of columns. So if the number of rows m, if I call it as m, not equal to n, generalization. If m is not equal to n, number of rows is not equal to number of columns, we call such matrices as rectangular matrices. So they are rectangular matrices. Example: A equal to 1, 2. Simple example: A equal to 1, 2. Here there are 2 rows. This contains 2 rows and how many columns? 1 column. 2 rows and 1 column. So 2 cross 1. Here itself you can observe 2 number of rows, 1 number of columns. This is an example for a rectangular matrix. Basically, just remember that rectangular matrix means number of rows not equal to number of columns. One more example: B equal to 2, 3, 4, 5, 6, 7. This is again a rectangular matrix because it contains 2 rows, 3 columns. We can have many examples: 3 cross 2 matrices, 4 cross 1, 1 cross 4. All are rectangular matrices. also a rectangular matrix. In this example, 0, 0, 0, 0, 0, 0. It is a null matrix, but this null matrix is also a rectangular matrix. On the other hand, if you consider 0, 0, 0 like this is not a rectangular matrix. What is the reason? 0, 0, 0, 0, 0, 0, 0. It is not a rectangular matrix. It is of order 2. Number of rows is equal to 2, number of columns equal to 2. So it is 2 cross 2. This is 2 cross 2. So it is not a rectangular matrix where, not a rectangular matrix in the sense number of rows equal to number of columns. So this is a case where number of rows equal to number of columns. Such matrices are called square matrices. So next topic is square matrix. Square matrices. Next type of matrices, square matrices. Square name itself suggests square. So even in you find areas, you have seen that square means so all the sides are equal. Analogous to that, here number of rows equal to number of columns. So a square matrix is a matrix in which number of rows equal to number of columns. That is m equal to n. So remember, rectangular matrix means number of rows not equal to number of columns. Square matrix means number of rows equal to number of columns. Simple example already given. One example is 0, 0, 0. Some other example I will give you. X equal to 1, 2, 3, 4. So it is a rectangular, it is a square matrix of order 2 or 2 by 2 matrix. So number of rows, number of columns same. Number of rows and number of columns. First always we specify number of rows. Next number of columns. Some more example. Y equal to 1, 2, 3. Any number can be given. 5, 6, 8, minus 9, 7, 4. So this is a square matrix of order 3 by 3. It is a square matrix of order 3 by 3. Okay, so square matrix means number of rows equal to number of columns. Next, diagonal matrix. Matrix is singular, matrices plural. Remember, matrix means one. Matrices means plural, more than one. So diagonal matrix. What is a diagonal matrix? Diagonal matrix is a square matrix. So basically, diagonal matrix is a square matrix where non-diagonal elements are zeros. I will explain it with an example. A equal to, simple example I will give you, 0, 0, 2, 1. This is the element I am referring to. Diagonal elements means I am referring to this element. Non-diagonal elements, in this case 1 and 2 are non-diagonal elements. Okay? Give like this. 1 and 2 are diagonal elements. These are 1 and 2 are diagonal elements. I mean across from left to down. 1 and 2 in this example are diagonal elements. Non-diagonal elements here. This is a non-diagonal elements. This is also a non-diagonal elements. These are zeros. So these are zeros. This 1 and 2 are diagonal elements. Okay. Now what is a diagonal matrix? Here the condition is these elements may be or may not be zeros, but these elements are zeros. This is called diagonal matrix. Next one, scalar matrix. Scalar matrix. Scalar matrix is a diagonal matrix. So first of all, it is a diagonal matrix. That means what? Non-diagonal elements are zeros. I will give you the same type of example. But what is the change here? The change is these elements, that is the diagonal elements, should be of the same value. So scalar matrix means here the diagonal elements should have the same values. So I am having 2 and 2 here. So one more example. See 1 1 1 or 3 3 3. Rest are zeros. So this is again an example for scalar matrix. Example for scalar matrix. And one more type I will give you, what is called as unit matrix. Unit matrix are also called identity matrix. Identity matrix. Unit matrix are identity matrix. I will explain it with the example. Say I will denote the identity matrix as generally as I, using the letter I, capital letter I. I will give an example. So what is the identity matrix? It is a scalar matrix, but the condition is the diagonal element should be 1. This is one example of identity matrix of order 2. Because number of rows and number of columns are 2 only. So I will specify that identity matrix of order 2. So remember here, identity matrix means you will have the value 1 as diagonal elements, rest are zeros. I will give one more example. I can give as 1 0 0 0 1 0 0 0 1. It is also an identity matrix of order 3. Order 3. It is of course 3 by 3 matrix. So it is an identity matrix of order 3. So for this class, I will wind up. We will have continuation of these topics in the next class.